You open your car door, sit in the left-hand driver's seat, and treat it as completely normal. The steering wheel sits in front of you. The mirrors are adjusted. The accelerator pedal rests beneath your right foot. This layout repeats across millions of vehicles worldwide. It appears to be a purely technical standard. Yet if you rewind 150 years, when internal combustion engines were still curiosities, the driver's position was shaped by something far more mechanical: the leather whip of a horse-drawn carriage driver. Before automobiles, there were Conestoga wagons in North America, massive freight wagons stretching 5 to 6 meters long, hauling tons of goods over uneven dirt roads. An adult horse weighs about 500 kilograms. A team of 4 horses pulling a wagon equaled the mass of 2 modern cars. Drivers needed precise awareness of the wheel's distance from the road's edge to avoid tipping over. They typically sat slightly to the left while holding the whip in their right hand. This posture allowed the whip to sweep across the horses' backs without striking the wagon body, while the driver's left eye monitored the opposite wheel to prevent collisions. That small ergonomic detail formed a positional habit. As wagons grew larger, drivers continued sitting on the left to optimize visibility and avoid accidentally striking themselves with the whip. This was not an aesthetic decision. It was geometry and inertia at work. By the early 20th century, when Henry Ford began mass-producing the Ford Model T, the automobile industry had no fixed standard for steering wheel placement. Some early American cars positioned the steering wheel on the right, but as U.S. road systems gradually standardized right-side driving. Placing the steering wheel on the left offered a clear advantage. The driver sat closer to the center line of the road, improving visibility of oncoming traffic during overtaking. Imagine a narrow 2-lane road in 1910. No reflective paint markings, no LED headlights. Average speeds hovered around 30 kilometers per hour, modest by today's standards, yet demanding, with rigid steel frames and mechanical brakes. Sitting on the left allowed drivers to estimate overtaking distances more accurately by several crucial centimeters. Those centimeters could mean the difference between safe passage and collision, especially when roads were only 5 to 6 meters wide. Ford did more than sell cars. He built a mass production ecosystem. When the Model T surpassed 15 million units between 1908 and 1927, each design decision multiplied millions of times over. Installing the steering wheel on the left in an affordable engine-ocean, widely accessible vehicle reinforced a national standard in the United States. As these cars spread, other manufacturers adapted to meet customer expectations and comply with traffic laws. What makes this particularly interesting is that the decision did not originate from a modern user experience brainstorming session. It inherited the logic of carriage driving and adapted it to prevailing traffic direction. The whip disappeared, but the dominance of the right hand, the primary control hand for most people, continued shaping vehicle layout. The accelerator pedal remained on the right because the majority of drivers have greater dexterity in their right foot. Over time, vehicle controls stabilized around the biomechanics of right-handed bodies. The story extends beyond America. In the United Kingdom and other left-driving countries, steering wheels are placed on the right to keep the driver closer to the road's center line. The same logic of visibility and overtaking applies simply mirrored. Design reflects traffic law, and traffic law reflects each nation's military and commercial history. Everything connects in a chain of cause and effect. For perspective, a modern Kirkconn's over Trent. 0, 0, 0 individual components. Each part operates within tolerances measured in millimeters. Yet the driver's seat, the very first point of contact, is the product of decisions stretching from 18th century wagons to 20th century assembly lines. When you lean slightly left to check your side mirror, you are using a viewing angle optimized across generations of vehicles. Now the story widens. As autonomous vehicles develop, the concept of driver position may shift. If algorithms replace human control, the seat could theoretically move to the center. However, Infrastructure,
Initial
road
acceleration
signage,
shows green
toll
pathway
booths.
activation.
Lane design has been built
As the
around the
foot
assumption
pivots
that
to
the
the
operator
brake,
sits offset
we
to one
observe
side.
the
Redesigning that entire system would cost as much as repainting hundreds of thousands of kilometers of lane markings, a logistical challenge of enormous scale. So the next time you sit in the left-hand driver's seat and place your hands on the steering wheel, remember that this layout
By
once helped
implementing
someone
this new
avoid
design,
striking
we
themselves
address
with
the
a
root
whip.
cause of the congestion,
Design rarely
ensuring
begins on
smoother
a blank
traffic and
page.
enhanced.
More often, it is the continuation of an older solution adapted to a new context. If seemingly ordinary details like this invite closer inspection, there are many more
Visibility has come
traces
a
hidden
long
inside
way.
the car's
See how the
cabin,
viewing
from
angle
the
has
gear
evolved
lever's
over
position
generations of
to the
vehicles.
arrangement of pedals. Each has a technical story behind it. And sometimes, that story begins on a dusty road with a person holding a whip in their right hand.